Hello, my name is Nick Huntington Klein. I'm an economist. I'm an applied economist working with data and statistics a lot in economics. And one question I get asked is, what is the best language for doing econometric work? And so that's what I'm talking about in this video. And to be clear, what I'm talking about is not all kinds of economics, but specifically the kinds of economics where you're working with data, you're working with statistics, and that sort of thing. I also want to be clear, what is the theory of what makes a good language or tool that I'm going to be bringing to this. And this is, I think it makes a lot of sense to use the kind of tool that is suited for the work that you are doing, which means that different kinds of tasks that you're doing might call for different languages being the best kind of thing. It also means that I'm probably going to favor tools that are a bit more custom built for doing the kinds of work that economists do. Right? Those are different criteria than things like what is the best programming language in general. That's a different question. Also, just as some general advice, whatever I say about these different tools, I think the real thing for what you should pick to learn, if you're like a student or something like that, the most important thing about a language is that you can use it with other people. A lot of time you're going to be co-authoring with other people, you're going to be working with other people, and the best language is the one that everyone else is using, because it means that you can work with them. You don't want to be the one person who doesn't know the language that the project that you're on is with. So, that's the real first criteria. But that said, there's different things that different types of tools are good or bad at, and we can talk about that as well. I also think in general, it's probably just a good idea to learn two languages. Learn whatever makes the most sense in your field, whatever other people are using, and then learn one other language, whatever it happens to be. And then once you've done that, it's going to be a lot easier for you to pick up new tools as they come along. So if you have a task coming along that might be better suited for one of the things that you don't know, then once you've learned two languages, picking up the tool that is best for that task is going to be a lot easier for you. With that said, let's get into the languages that we are going to cover today and their pros and cons. So the first one that we're going to talk about is Stata. So Stata is a language that is for economists. It is for economists first and foremost. I know that other fields also use Stata, especially in the social sciences, but it is a tool that is really built for economists to use. As you go through the documentation, you see lots of economics examples. The kinds of functions that are made easy to do are the kinds of things that economists want to do frequently. It is custom built for you as an economist. So that has a lot of pros to it. It means that you get a lot of economics-y details in the documentation, right? If you want to know, hey, is this command that looks like it's sort of similar to this paper that I know, is it actually related to that paper? Yeah, and they'll cite the economics paper as opposed to having to dig around to see whether or not this model actually does match things. It also means that the syntax often is in a way that is catering to what you are doing. And it's relatively simple because it is geared towards economics and not too bothered with trying to do other kinds of things. Then if you're just doing econometrics, then, it is probably going to be easy mode for you to be able to do the thing that you want to do. Of course, there are downsides to this as well. And a lot of that comes when you're doing anything besides econometrics, right? There are a lot of tasks that you would need to do in the process of doing data analysis that are not econometrics. Things like cleaning your data. Stata is not a great language for cleaning your data in. Again, you can do it, but it's not great. Once you've used any other tool for cleaning your data, you will realize the deficiencies that Stata has. Things like, making it not very easy to have more than one data set open at a time, not having easy access to things like vectors. It's also not so good when you have to do other kinds of analysis, right? You can do machine learning of some sorts in Stata. It's slowly becoming more available. But if you expect machine learning to be a thing that you do with some regularity, then Stata is just not the best choice for doing that in. It's also not very well suited to being able to do your own thing. If you want to use a pre-packaged estimation algorithm, Stata is fantastic for that. But writing your own estimator, you have to start working with stuff like Meta or other kinds of things, and that's really hard. In fact, I started out using Stata. That was the first language that I really learned how to do data analysis in, and the thing that kicked me out of it was trying to program my own estimator and realizing that it'd be much easier in pretty much any other language. So those are some of the downsides of Stata. In addition, it's not that great at handling large data sets. If you want to use a large data set with millions and millions of rows, Stata is going to choke on it. And the time that you're going to spend with Stata crashing and reloading, you probably could have just learned another language that can handle it a lot easier in the first place. So to sum up, what it's good at, if you just want to run an econometric model, it is fantastic for that. It is purpose-built for that task. If you want to do other stuff, clean your data, work with big data sets, do machine learning, it's not so great. Next up is R. So R is a language that is built not for economists, it's built for statisticians. But econometrics gets a lot of play in there, and it's well supported in the language. And I will say that the ability to do really good econometrics in R is a relatively recent thing. When I first used R in my undergraduate statistics course back in like 2007 or something like that, I don't think it would have been a good place to do econometrics in. It was much more focused on statistics and other fields that use statistics in other ways. But in the intervening years, the development of econometrics in R has been very, very strong, with packages like, for example, fixest, providing pretty much anything that an econometrician would want to do. It's much faster than Stata and allows you to get access to a lot of machine learning tools that you would not have access to in a more dedicated language like Stata. It is, as I mentioned, quite fast. In benchmarking tests of different languages for doing different kinds of data analysis or cleaning tasks, R often comes out as the fastest option, especially if you're using fast packages like data table within R, although some languages are nipping at the heels, like Julia, for example. We'll talk about that later. It also has access to a lot of things that you would probably want to do as a researcher, which are not necessarily just running a model. It's very good at data cleaning. Like I said, it can work very well with large data sets. It also has a lot of good capabilities for graphing. The graphing capabilities in R are perhaps the best of any language. It also has a fantastic IDE, integrated development environment, in RStudio. RStudio is really fantastic. I've tried other programs for running languages, other kinds of IDEs. For example, I've been trying in Python for ages to find one that is as good as RStudio, and it's just not out there. It is a really good program for being able to run R in. It gives you access to a lot of different things. It's also fairly actively developed, so you can expect that new estimators, the new fancy fun tool that you want to use, probably is going to have an R package available for it relatively soon. Sometimes you even see R packages for very economics-y kind of new things before you see them in Stata, even though the Stata is where all the economists are, because R is just simply much easier to develop a package for. Now, of course, there are downsides to R as well. R is a relatively old language, older than some of the other ones that I'm going to cover coming up soon. And so there's some just weird idiosyncrasies of stuff that got decided on in 1994 or whatever and just still happen to be hanging around. And sometimes you have to work around those things. You sort of get this weird system where in R, it's developed for data analysis and you can do everything in base R, more or less. But then you don't do it in base R. You use the packages that sort of surround you. So R gets sort of divided. If you're looking for help online, sometimes you get R help that uses base R, and sometimes you get R help that depends on packages. So you get sort of a divided environment in that way. Because of this, you can sometimes get different approaches to solving a problem that sometimes talk past each other entirely. And if you're used to, for example, using tidyverse functions in R, sometimes you might find difficulty, right? If you find and you have a question about what to do, you search online and all the explanations use data table or use base R, and suddenly you don't exactly know what to do with that. It's like you're using several different kinds of languages at once. So that's a downside. Also, compared to some of the other languages here, when you're talking about the private sector, R is used fairly frequently in the private sector. Behind Python, it's probably one of the more common ones that you'll see if you want to transition to a private sector job. But there's also, I mentioned those idiosyncrasies, it's not really developed for things like putting into production code, and there can be some difficulties in doing that. Additionally, while there's plenty of active development in R, I count myself as a developer in making R package and things like that, it is not as active as some other rising languages. And so the advantage that it currently has in the availability of econometrics packages or just development generally and machine learning and stuff like that, maybe it won't hold that edge forever. Moving on, we have Python. You've all heard of Python, I'm sure. So Python is a language designed for computer science. It is a general purpose programming language, more so than the other languages on this list, which are more designed for doing data analysis in. So Python, of course, has a lot of data analysis capabilities, but those are sort of like add-ons. To do pretty much anything with data, you're going to need to load a package, which is also true. You're going to be loading packages in a lot of these other languages, but usually those are sort of additional things you can do with data analysis. You don't need them to get started with data analysis. So the main focus of Python is for doing computer science work more generally, and then there is a system of packages that you can download like NumPy, SciPy, Pandas, stats models for doing actual analysis in. So there's something that Python is really fantastic at, and that is because it is a general purpose programming language, it's really good at if you're not just doing data analysis and cleaning. If you want to do some data analysis and cleaning in a project that also includes things like building a web scraper, making production environment code, any of that sort of stuff, Python is probably your best bet because it is capable of doing those things better than pretty much any of the other languages on this list. It also has super active development and a huge community. It is the most popular language on this list by far. Which means that any capability that it can't do right now, it might be able to develop in the near future. But then again, it's not really focused on data analysis, so a lot of the community that's developing Python is not doing that sort of thing. But that said, you're only getting the crumbs, but it's a really big table, so there's a lot of crumbs. Now for the downsides. So as I mentioned, Python is developed for other things besides data analysis, and doing data analysis in Python is sort of like, oh yeah, we managed to do this too. And you can really feel that as you're doing data analysis work, and especially econometrics in Python. It's not designed for it. And so you run into some weird cases where using it just doesn't feel right, or the setup is clearly designed for a different use case. And you can use it for econometrics, and apologies to people who do use it for econometrics, but I've yet to understand why you would. I've been trying to really learn a lot of Python recently, and the more I learn about it, the more it feels like this is really not a tool for me. I can get in the room, but it's just not for that. It's sort of like a sports bar, right? I don't watch sports. I have no interest in sports. I could go into a sports bar and get a drink, but it's designed for other people. Even if they're willing to change the TV to something else for me, I'm not going to rave about it just because I happened to be able to make it work for me. It's for other people. This really shows through in econometrics, right? This is a language for statisticians, and then secondary to that, they have data scientists, and secondary to that, they have statisticians, and then secondary to that, they have econometricians. The econometrics capabilities in Python are currently a little bit limited. Doing regression-based work in Python feels kind of difficult, and the packages often have some very weird elements to them that don't quite work. Stats models in particular can be kind of difficult to work with. Now that said, like I said, Python has a very active development in a lot of ways. And certain things that it could not do in the past, pretty basic stuff, those gaps are going to get filled in as time goes on. Even in just the past couple of months, we've seen developments of packages that do like the new versions, all the new estimators, the difference in differences. Just today, as I film this, the beta version of the R fixest package became available. And so the development is happening. And I suspect that econometrics in Python will get better over time. I would not recommend it right now unless you really want to do econometrics alongside those other things that are not data analysis that Python does do very well. Next up is Matlab. Matlab is, of course, a classic for econometrics. And in my case, Matlab is what I did my undergraduate econometric classes in. And the reason for that is that it's very good at when you want to get your real hands on data and work with it by yourself, as opposed to using a prepackaged estimator. Certainly there are prepackaged estimators for things like linear regression in Matlab, but it's really designed for where you're designing your own stuff. You're writing your own estimators, or perhaps you're doing some sort of direct structural modeling, which you can do very easily in Matlab. Because it's quite old and been used heavily in econometrics for a long time, there's a big code base that you can borrow from. You can get other people's code and see what they've been doing in Matlab. It's also quite intuitive and easy to use. It's largely just written, you just write out what it is that you want. And I found when I was working with Matlab, I often didn't even have to look up any code because I wasn't really using any code. I was just doing matrix algebra. That's what it's good at. It's what it's for. And so most of the time, what you're supposed to do is quite intuitive. It's hardly even a language. You're just sort of working with the math, which feels really good. It's also got a pretty good user interface. Outside of RStudio, it's one of the better user interfaces, one of the better IDEs in this area. So there's a system in there. You open up the Matlab program, and it's got a lot of tools that make working with the language a lot easier. Now about the downsides. Matlab is a very old system, and it is kind of showing its age. It's quite slow compared to a lot of the other languages in this list, especially the next one that I'll talk about, which is Julia. There's just some weird language idiosyncrasies that are there that seem left over from a long time ago and just aren't really the way that you do them if you had a chance to do it all over again. It's also expensive. Now, you have to buy a license for Matlab, just like you would with Stata. I didn't mention it as a downside for Stata, but Stata is expensive, Matlab's expensive. Everything else on this list is free, or you probably already have it. So you do have to pay for it, which doesn't feel great, which is fine if you're in a university and they're paying for it for you, but you gotta be sure that you're always going to be in that university, because if not, then you are going to have to shell out a couple $1,000s to get continued access to the language that you happen to know. So if you do happen to learn one of these closed source languages that you got to pay for a licensing fee for, that's really a case where you also want to know another language in case you ever lose access to that license. Next up is Julia. Now, Julia is the language that I actually have the least experience with on this list. It is you can sort of envision it as a new, free, open source version of Matlab. Sort of. It's not quite like that. But it is a very fast language designed for doing data analysis as one of its primary goals. And it's also, like Matlab, one where you can really directly work with the data itself in a very easy way. You can do a lot of things like writing your own estimators is very easy to do in Julia, or doing structural modeling. You can even do cool things that they wouldn't have thought to put in a language 20 years ago. Like, for example, you could do programming and have your variable names be Greek letters. I think that's just neat. That's the kind of hint to me that, like, this tool is designed for what I want to do, right? It's that nice hint that sort of tells you you're in the right bar. It's also very fast. Julia and R sort of trade off depending on what task you're looking at being the fastest at doing that particular kind of task, whether you're talking about reading in large files or doing particular kinds of summarizations or running particular kinds of models. Usually the fastest option is going to be in one of those two languages. Now, I will say, on the list, this is definitely the junior option. This is the newest entrant into the list. And because of that, some of the development is not quite there yet. If you are planning to do the kind of thing where you're writing your own estimators, great. But if you're planning to use a pre-packaged estimator of some sort, well, a lot of those aren't in Julia yet. They just haven't had the time to be written. And so, if you are hoping to not have to write your own estimator, you're probably going to be better off with something like Stata or R, or in some cases even Python. That said, development is quite active, and we expect that a lot of those holes are going to get filled in more and more over time. Also, it's not just newest, it's also the least popular of the options that I'm presenting on this list, although I'm not sure exactly where it stands relative to Stata, but in economics at least, it's definitely the least popular. Because of that, you are going to have a little bit of a harder time finding support. You're going to find a little bit less Stack Exchange answers for how to do a particular thing for Julia than you will for any of these other languages. So it seems like a really great system. I'm very optimistic about it, but I also haven't bothered to really learn it because the support's just not there yet. So this is something where you'd be getting it on the ground floor and hoping that the development sort of catches up with your needs relatively soon. Lastly, let's talk about Excel. So Stata was for economists, R was for statisticians, Python was for computer scientists, Excel is for accountants and business analytics. That's what it's designed for. And any sort of statistical analysis that you can do is sort of a secondary thing. They have a data analysis plugin that you can use that does things like regression and correlation and things like that. So Excel is great. You should learn how to use Excel, absolutely. I wouldn't recommend that any researcher not know how to use a spreadsheet. I'm saying Excel, but really Google Sheets stands in for a lot of this as well. And spreadsheets are great for doing things like estimating a single number or doing a basic calculation where you're not really doing statistical work so much as you have some numbers and you want to know a basic calculation from the basis of that, right? What's my compounded interest going to be if I hold this thing for 10 years, right? That's a good question to ask a spreadsheet. On the downside, it's really not designed for doing statistical analysis in. You can, but sort of like Python, I'm not really sure why you would. It's just really not the best tool for the job. A lot of the things that you would do in a spreadsheet are pretty bad ideas when you're working with data. Things like being able to edit the data directly without leaving a paper trail to know what you did. Or things like having a maximizer that just doesn't work properly if your model's not statistically identified. There's weird errors that go in there, or like maximum row lengths. You've certainly heard all the horror stories about people who use Excel for data analysis getting weird results they didn't expect because Excel is not designed for data analysis. So it's difficult in that way. It's also just difficult to work with. Anytime I see somebody doing some sort of statistical analysis in Excel, there's some smugness in the world of programming languages for data analysis. I recognize that. That's not what I'm trying to say. I'm not trying to say that, I can't believe you're using Excel. You can't bother to learn anything else. It's just painful to watch people try to use it for this purpose that it's really not designed for, because it makes you work so much harder to get there. Without making mistakes. There's opportunities for mistakes everywhere that are hard to catch and are just so much easier if you happen to learn a programming language. Excel is a very powerful tool and you should learn it for other purposes, but for doing the kind of statistical work that economists tend to do, it's just not a great tool, and I don't recommend doing your econometrics in it. That said, if you're living a life where you do a regression like once every 5 years or something like that, yeah, you could probably get away with doing it in Excel and not having to bother to learn any sort of statistical analysis programming language or anything like that. But that's sort of like in Python, right? If you're mostly doing other stuff and occasionally you need to run a regression or whatever, yeah, fine. You can get away with it. It works. But for any sort of, if the main thing that you're doing is data analysis, statistical analysis, it's going to be worth your time. And I don't mean this in the sense that these others are better or like it's cool that they have to learn a language. I mean, it's going to save you time. It is easier to work in those languages once you know them than to work in Excel. And that's, a lot of stuff that Excel power users are like, yeah, but you can do all this cool stuff in Excel. Yeah, it's like one line of code, and it's not that impressive in a language that is designed for doing that. All right, so that is my rundown of 6 different ways that people commonly will do econometrics, and the pros and cons for each of them. Each of them has a place, and each of them has some downsides as well. Pick the tool that is best for what you are doing. Now, of course, there's plenty of stuff that I left out as well. I didn't talk about Gauss or eViews, a lot of those sort of time series centric tools. I didn't talk about, people are still using Fortran for stuff, right? But these are probably the 6 that are most commonly applied, especially when you're talking about more general kinds of data analysis, the kinds that economists tend to do. All right, so that is it. Thank you very much.